Hey everyone, welcome back. This is lesson 9, radicals, a mixed review for simplifying. So a quick warm-up I'd like you to do is answer this question. This was a question on a Regents exam. Is the solution to the quadratic equation written below rational or irrational? Justify your answer. So I did a few steps, and again, we talked about how some of these steps you're going to be learning in Algebra 1B, but I skipped down to the step that I would take the coefficients here, I would plug them into the quadratic formula, which we talked about in our last lesson, and this is the answer that I would get, the simplified answer I would get after plugging those answers into the quadratic formula. So at this point, my real question is this equal a rational or an irrational number? What do you think? Well, I originally said, I'm going to start simplifying this radical. And then I realized, well, I don't really have to simplify it. I just have to figure out, is this whole thing rational or irrational? So what I did was I actually plugged it in my calculator. Now, I don't know if you know, but there is not a plus or minus button in your calculator. So what I'm going to have to do is I'm going to have to write this in my calculator and see if this is a rational or an irrational answer. And I'm also going to have to check this in my calculator and see if this is a rational or irrational answer. Again, this symbol up here means plus or minus, and that's how we read it. So when you solve these, there are two separate answers. There's a positive answer and there's a negative answer. And we talked about that when we first started our radicals. When we have a square root of 9, let's say, the square root of 9 actually has two different answers. It has a positive answer and it has a negative answer. We typically use, because we're dealing with real-world concepts, we typically deal with the positive answers, but on occasion we're going to deal with negative answers as well, and just know that those exist. So I just typed this in my calculator, -3 plus the square root of 89, all divided by 2. I used my alpha y equals to get the fraction, so it looks just like I wrote it here, and I got this answer, 3.216990566. That looks like it's going to be irrational. Because it is a decimal, it looks like it continues on. Because my calculator stopped does not mean the decimal stops, and there is no pattern in the decimal. What I'd like you to do is put this into your calculator, write down the decimal, and tell me, is it rational or irrational? In order to show appropriate work for this problem, not only would I have had to show all of this work that I did with the quadratic formula, but it's specifically asking, is it rational or irrational? You do need to answer that question. Is it rational or irrational? And then it says justify. And remember, we talked about the word justify. The word justify means just show your work. All right? It's very different from the word explain, which you would have to write sentences for. Justify, just show your work. All right, so be sure you plug, again, your task right now is to plug this second one into your calculator, write down the decimal, and tell me, is it rational or irrational? Once you do that, pause the video here. Once you do that, we'll move on to the next problems together. So our final two problems are going to be these guys right here at the bottom of your worksheet, simplifying, just some more practice. So what you're going to have to do, again, I would highly recommend, if you're not confident with what to put in your calculator to start this, remember, if you type the whole thing in your calculator, and even if you just type the radical in your calculator, most likely you're going to get an irrational answer. So just doing that and writing the decimal is not simplifying. You want to simplify it, and typically the directions will say simplest radical form. So they're not looking for a decimal equivalent. They want it in simplest radical form. They want a radical in your answer, but it has to be simplified. So again, I would recommend watching that video if you're not sure where to start. Hopefully you do know where to start because you've watched the video a few times. And that's okay, because that's what we do when we practice something. You want to learn a skateboard trick, you have to practice it. Not just once, not just twice, not 3 times, a lot of times. So be sure you're doing this with me on your calculator right now, and if you're not confident with it, go back, take the time, watch the simplifying videos, simplifying radicals video on the calculator videos links. All right, here we go. So I first need my perfect square list. So I'm going to do that just because I don't have it from memory. I'm going to type in x squared, and I'm going to look at this list, and I'm going to jot it down on the side of my paper over here. It looks like I'm going to have to go pretty high because this number is 128, 25, 36, 49, 64, 81, 100, and I'm going to go like just one more. So let's move down until I get. And again, I'm copying the perfect squares down. All right, 121. That's going to be the highest possible number, but it's not probably going to go into 128. All right, back to y equals. This time I'm typing in my number under the radical, 128 divided by x. Again, I'm looking for numbers that divide in evenly, and that's what I'm looking for to find one of these numbers, hopefully, on it. And I'm looking, I start at the top, 128, and I work my way down. And 128 is not on my list, but 64 is on my list. So that is the number I'm going to use. That is the largest perfect square on this list and on this list. And that's all I have to do. Now I'm going to rewrite. So 3 is just going to stay on the outside, and I'm going to break this radical up into two different radicals. My perfect square, which is the 64 that I found on my list, and the not perfect square, which is the number across from it. So 2 times 64 makes 128. So since my 2 is going to be an irrational, the square root of 2 is going to be an irrational answer, I'm going to put it in my second square root. Perfect square in the first one, non-perfect square in the second one. So far, so good. Again, the reason I always put the perfect square first is for this next step, actually. I can put this whole thing in my calculator because I know that the square root of 64 is a perfect square, and it will come out as a whole number. So I'm going to type that in right now. 3 radical 64. And there you go. So the square root of 64 is 8, and 3 times 8 is 24. So that's basically what that just did. So that whole thing just simplifies to 24, but my square root of 2, unfortunately, has to stay because that is the irrational part, right? And that is my final answer. Again, one final check, something good to do, right? Looking at my original decimal, 33.9411255. I'm going to type in my answer, and hopefully the decimals match. If they do, then I know I did it correctly. And there you go. They match. So I'm good. A little check for myself, making sure that, I know I did it right. All right, so let's look at this next one. Square root of 6, the square root of 6 over 25. First thing I'm going to do is I'm going to try this out and just put it in my calculator, just because it's so weird, and I don't think I've ever seen anything like that before. So I had to use my radical, and then I had to use my alpha y equals to get the fractions. Let's see what happens. Ugh. Okay, it's definitely an irrational answer. What's really fun about doing simplifying is I already have a list of perfect squares here. And I don't know if you noticed this, but 25 is on the list. Huh. So maybe the 25 part can come out of my radical. Maybe. So what I'm going to do is actually going to break this up into two radicals. I'm going to leave the 6 alone, because I guess that's the irrational part. But the 25 I'm going to move over here. But 25 is, in this fraction, is not just 25, right? It's 25, but at the bottom of a fraction. So since I moved the 6 over here, what's left here? Well, just a 1. I can't leave a 0 there. I can only leave a 1 as a placeholder. So I'm going to, let's try this again. Try radical 6, definitely the irrational part. I'm going to try the square root, and I'm going to go to alpha y equals to get that fraction. I'm going to do 1 over 25. And it comes out nicely. 25 is on my list. So this whole thing just becomes plain, right? No radical, plain 1/5, right? Radicals all gone. And then the 6 is going to stay inside my radical. Making sure, one more time too, not only am I going to check in my calculator, so the square root of 6 over 25, 0.48989799486. Now I'm going to do and check 1/5, arrow out, times the square root of 6, arrow out, and it's the same exact decimal. I can arrow up. Just double check it, right? There you go. Yep, exact same decimal. And that's it. And that's all you got. So again, if you're not sure about the steps that I just did on my calculator, a good video to go back and rewatch would be the Simplifying Radicals video using your calculator. Hopefully you got all these notes down, and I look forward to seeing you in class.